In this video, we're going to look at product rule for higher roots. So we have removing perfect nth roots from the radicand. If necessary, write the constant term in prime factors. For each factor in the radicand, divide its exponent by the index. The outside exponent will be the quotient, and the inside exponent will be the remainder. And the example is the cube root of a to the 20th is equal to a to the 6th times the cube root of a squared. And 20 divided by 3 is 6 with a remainder of 2. So the 6 ended up on the outside and the 2 ended up inside. And then simplify further if necessary. And then note, after simplifying, the radicand should not contain any factors that are the nth power. In 1, simplify if possible, assume all variables represent positive real numbers. So in A, we have the cube root of negative 81. And we can rewrite that as the cube root of negative 27 times 3. And then the cube root of negative 27 is negative 3 times the cube root of 3. In B, we have the sixth root of 64 x to the 7th y to the 6th. So I'm going to rewrite 64 as 2 to the 6th power. And then we have x to the 7th, y to the 6th. And now the sixth root of 2 to the 6th is equal to 2. And the sixth root of x to the 7th is going to be 1x on the outside, and then 1x still inside the radical, because 7 divided by 6 is 1 with a remainder of 1. And then we have the sixth root of y to the 6th, which is y. So we end up with 2xy times the sixth root of x. In C, we have the sixth root of negative 64. And because we cannot take an even root of a negative number, this one is not possible. Now it says the product rule for higher roots. Let the nth root of a and the nth root of b be real numbers, then the nth root of a times the nth root of b is equal to the nth root of a times b. When simplifying using the product rule, the radicand should not contain any factors that are perfect nth power. This means the radicand cannot contain variables with exponents greater than or equal to n. And simplifying expressions containing nth roots. Use the product rule to write as a single radical. Simplify the radicand using the laws of exponents. If helpful, write the constant and prime factors. 3. Simplify the radical by removing perfect nth powers from the radicand. And 4. Simplify the expression if necessary. So in 2 it says simplify, assume the variables represent positive real numbers. And in A we have the cube root of 25 times the cube root of 25. And it wants us to write as a single radical. So we can say that this is equal to the cube root of 25 times 25. And now it wants us to write the radicand in prime factors. So we have the cube root of, now 25 is the same as 5 squared times 5 squared. And that is equal to the cube root of 5 to the 4th power. And now it wants us to simplify the radical, so we can say that this is equal to, now when we have 4 divided by 3, it's 1 with a remainder of 1. So we're going to have 5 times the cube root of 5. In B, we have the fourth root of 8x to the 5th times y to the 7th times the fourth root of 4x to the 15th y to the 5, and it wants us to write it as a single radical. So we have the fourth root of 8x to the 5th y to the 7th times 4x to the 15th y to the fifth. And now it wants us to simplify the radicand. So we have the fourth root of 8 times 4 is 32. X to the fifth times x to the 15th is x to the 20th. Y to the 7th times y to the 5th is y to the 12th. And now we want to write the radicand in prime factors. So we have the fourth root of 32 can be written as 2 to the 5th. And we have x to the 20th, y to the 12th. And now we want to simplify the radical. So we have 5 divided by 4 is 1 with a remainder of 1. So 1, 2 comes out of the radical. And we'll have 1 left inside the radical. And then we have x to the 20th. So 20 divided by 4 is 5. So we have x to the 5th. Y to the 12th. 12 divided by 4 is 3. So y cubed. And then we have the fourth root of 2 remaining inside the radical. And that's our video on product rule for higher roots.